Hello, Longhorns. Today we're going to be talking about lesson number 1, coming out of chapter 7, pages 192 and 193 in the textbook. Of course, we're talking about momentum. Even when you look at this word, the number one thing I want to jump out to you is that momentum kind of reminds you of the word motion. All right? So keep that in the back of your mind. Anything which is moving has momentum. And this is kind of where those questions come from that don't include numbers. They just want to make sure you understand fully the concept that's being presented. So if I'm running, I have momentum. If I am not moving, there is no momentum. And we'll give you a good example of why that is. The other thing is momentum depends on two very specific things that you guys have heard before. The first one is mass, and mass is measured in kilograms. The second thing that momentum depends on is going to be velocity. Remember, velocity is a vector. It tells you both magnitude and direction. Mass is measured in kilograms and velocity is measured in meters per second. The formula we're going to learn and be working with is in the blue box on page 193 of your textbook. And it looks a little like this. Momentum equals mass times velocity. You already know that mass is represented by a lowercase m. Velocity is represented by a lowercase v. Since we already used the m, momentum will be represented by the letter p. So our new equation, p equals m times v. Mass is measured in kilograms, velocity is meters per second, and when we are looking at momentum, we're simply putting those two units together. Now, here's a good example. Tennis ball. Find the momentum of the following object. Just like we would with our normal guess method, it's nice to always label your variables. That way you're pretty in tune with exactly what you have. The tennis ball has a mass of 0.06 kilograms. How do you know its mass? Because we're using the units to guide us. So our first number is our mass. It is moving at 30 meters per second. Well, we just learned that our equation includes velocity. And they want you to find the momentum for each of these. So P would be my unknown. If you think about it, what would be your equation to solve this problem? Momentum equals mass times velocity. Go to step 4 of the guess method. Are there any units that we need to change? Mass is in kilograms, velocity is in meters per second, so there are no conversions taking place. I'm going to plug in my numbers. My mass, 0.06. My velocity, of course, is 30. And I come out with the answer, 1.86 kilograms times meters per second. Here's a second example. You're given a cement truck. We have 40,000 kilograms, which is your mass, along with 20 meters per second, which is your velocity. And for all these problems, of course, we're looking for momentum. Take a second, and I want you to see if your answer matches my answer. Our equation is the same. Momentum equals mass times velocity. We're going to plug in our numbers accordingly, 40,000 kilograms, along with your 20 meters per second. My final answer is 800,000 kilograms times meters per second. All right? Now, with every lesson, there's going to be an exception. And this next example definitely shows you the exception. We have a boulder that is a part of a waterfall setup. The boulder has a mass of 1,000 kilograms, but the boulder is at rest. If you had a chance to watch the first intro video on the guess method, we talked about different words that can represent numbers. And this is definitely one of those. If an object is at rest or is coming to a stop, its velocity will be equal to 0. So we know that this will make our velocity 0 meters per second. We're still looking for momentum. That hasn't changed. So your equation, momentum equals mass times velocity. P equals M times V. I'll plug in my numbers. My mass is 1,000 kilograms. The velocity is, of course, 0. In the end, anything times 0 will give you 0. So my answer is 0 kilograms times meters per second. If you're ever asked a conceptual question, an object is at rest. What is its momentum? Your answer is 0. Because remember, momentum and motion go hand in hand. Now, look on page 193 and we'll work practice problem number 1. This is another great chance to pause the video, set up your guess method, and determine what your answer will be. And then come back and we'll work this out together. On page 193, here's practice problem number 1. A deer with a mass of 146 kilograms is running head-on toward you with a speed of 17 meters per second. You are going north. Find the momentum of the deer. It's time for a little guess method. The first step in the guess method, of course, is our given. A deer with a mass of 146 kilograms. M equals 146 kilograms. Is running head-on toward you with a speed of 17 meters per second. 17 meters per second. You are going north. Whoa. If I'm going north, I have a direction. So I have magnitude and direction. Will this remain as speed or is it really velocity? You got it. Speed is a scalar quantity. It only tells you magnitude. Velocity is a vector quantity. It's going to give me magnitude, how fast I was going, and the problem gave us in what direction we were going. Find the momentum of the deer. What is our unknown? It's going to be momentum. Now, has your equation changed that you learned earlier? Nope, it's our equation of the day. So we would use P equals M times V. When it comes to substitution, is there anything that we need to convert? Mass is in kilograms, velocity is in meters per second. I'm going to say no, we're all good. So for our substitution step, there's nothing that has to be changed, along with the setup of our problem. The last thing you're going to do is solve your problem. So let's plug in what we have and see what we end up coming out with. All right, P equals M, which is 146 times V, 17. 146 times 17 should give you a pretty nice number. We're looking at 2,482 kilograms times meters per second. This would be a great time for you to attempt practice problems number 2 and number 3. If you happen to get stuck, don't worry, in class, we will tackle this concept again. And you'll have a head start because you've had a chance to look at your notes, the PowerPoint presentation, and you're going to come in with questions. As always, feel free to email me, and there's an additional link to a support video in the last slide of the PowerPoint. I'll see you in class.